Have a copy of the answer key. No, Star's missing it. Huh? This is the scoring rubric for the AP free response questions that I assigned. Okay, Mr. Anderson is passing out the DYUs that we started going over yesterday. I finished scoring them and provided a minimal amount of feedback, but we're about to go over the last couple of things that we really need to pay attention to. Hey guys, one of the things I cannot emphasize enough, I'll count the arrow up there, although it might keep you awake, who knows. One of the things I cannot emphasize enough is that we're getting off of Canva and our SGA stuff and focusing on stats in class. But more importantly, what I cannot emphasize enough is even on multiple choice, draw it out. Okay? On the AP exam, if you try to look at multiple choice questions and do it all in your head, you're going to have problems. On the free response, on the AP exam, if you do not show rhyme or reason of how you got to your answer, you cannot get partial credit if you get it wrong, and usually you'll only get partial credit even if you got it completely correct. You have to show where you're getting ideas from, because it's not just about getting an answer. It's about being able to clearly communicate those ideas. Statistics is all about communication of these ideas. So, I say all that. I don't think I updated the agenda. Oh, quick note about the test. So, I have two options for you, and I'll let you all vote. You just need to be aware of what will happen. We can either take the test. So, like, today we're going to go over, I should say this, finish DYU analysis. We're going to go over the AP free response. I should have put that in there. And then we're going to start bivariate data. We can either take the test first thing in class tomorrow, or we can let it go an extra day until Thursday to give some of y'all a little bit more time to study, maybe come in before school or after school to ask questions, and then take the test on Thursday. Okay? It is your choice. I am more than fine giving on either of those days because the test is ready to go. Okay? I will ask for your input at the end of class. Don't let me forget to ask. But I will let you make a decision about whether it'll be tomorrow or Thursday. If it is Thursday, by the way, I might go over one free response question tomorrow, but tomorrow will be dedicated to bivariate data, which is what we're going into. But that gives time for you to come in before school, come in after school, watch videos, whatever you got to do to prepare for that test. Okay, so think about that. Think maybe through lunch. I'll ask after lunch.
Mr. Penny.
Yes, ma'am.
You have a visitor.
Oh, finally! I paid for this like 2 weeks ago.
That's false.
I know, but thanks. Okay, so don't forget we should have everything on these proficiency scales down. Please do not forget to use your proficiency scales to drive your studying, to drive your thinking. I'm telling you ahead of time, these are the key terms and concepts you need to understand and be able to use, and here's the application, right? Like, this is what you can do. By the way, I don't know, we talked about it, but we didn't have a formal lesson on it. How do I know if a distribution is actually approximately normal? It has a bell curve, but there's something beyond that. There's something else. Huh?
It's a unimodal.
So it has that bell curve. It's unimodal, it's symmetric, but there's something else. And don't forget, it follows the empirical rule, which means we need roughly how many standard deviations on either side? 3. Do not forget that. So if you're ever asked about a distribution, or if you're asked, hey, can you use the empirical rule here? If it's not approximately normal, can't use the empirical rule. And if it doesn't follow the empirical rule, it's not what? Normal. That's an important relationship there. So that's all that I'm saying when I say assess the normality of a distribution. Okay, so we need to go over this DYU. The 10... I think everyone got an E, unless I just made a mistake. Everyone got an E on 10A, so I'm going to skip that one for the most part. Hey guys, if I were you, and one, ask questions about empirical rule, ask questions about the using z-scores here, because it's kind of like the last hoorah with this a little bit. If we are working with the normal distribution, I'm personally going to draw my own normal distribution for every single question. Every time. That's not... me, Mr. Kinney, saying that you should draw a normal curve every time. That's saying me, Mr. Kinney, who has taught this for 6 or 7 times now, I would do this. So if I'm going to do this, What should you probably do?
Do it.
Yeah, you should probably draw the normal distribution. Do you have to? No. Can you get the right answer without it? Without drawing it out? Sure. Is it easier to make mistakes that way? Yes. I'm trying to give you a foolproof draw it out. Because it's really easy to forget if I'm supposed to use normal CDF or am I supposed to use inverse normal. You draw it out, things are way easier. Okay? You create your z-score, things are way easier. Draw this sucker out. Right in the middle, it's going to be what z-score?
0.
And what's at that point of inflection? 1. And then you just use that until you fill it out on both sides. And notice, I'm just putting the z-scores. I'm not worrying about putting the true mean and standard deviation in there. But some people here found the z-scores and found the area between them. Hopefully, do I need to explain at all why 145.5 and 168 are negative 1 and 2? We good with how I got that? Okay. So just remember that's 1 standard deviation below the mean, that's 1 above. So I'm literally looking from here to here. So all of this in between. I've said this a few times. I like to play a game of what? Halves. Some of us found what this little piece is and use the 68, that's totally fine. But if I'm looking at 1 below to the mean, I know that's half of what? 68. If I'm looking from the mean to 2 above, I know that that's half of 95. Remember, 68, 1 standard deviation, 95, 2 standard deviations, 99.7, 3 standard deviations, right? So between negative 1 to 1, negative 2 to 2, negative 3 to 3. But now I'm playing to the mean. I'm playing a game of halves. So 34 plus 47.5 is equal to 81.5% of the data, or of test takers, would score between a 145.5 and a 168. If an AP reader is reading what I just did, can they follow that to clearly understand where I got my 81.5%? Especially if I've got this drawing there, and I show the half of 68, half of 95, that's clear communication of how I'm getting it. Draw it out. Shade it. Make your life easier, not harder. And again, these are your notes. Like, this is your DYU. I would write whatever notes that you need to make sure you do it better next time. There we go. Got 2 of us taking notes. Adding whatever you need to. You're not turning this back in. That's yours to study from. Whatever notes you need to take. If you need to talk about playing a game of halves, or you could just get a pencil out.
Yeah, but then it's like, did I write it or did I keep that on the pen?
Gotcha. So guys, I'm just trying to give you a hint. Empirical rule is easy. Don't forget, when can you use the empirical rule? What has to be true? Has to be a normal distribution, and there's one other key thing. And we'll point this out. I can't use the empirical rule on numbers, or on C. Why not?
Because you only have these
I'm talking about on C right here.
Because that doesn't follow the.
It's not an integer number of standard deviations. Guys, you cannot forget, the empirical rule only works when you have an integer number of standard deviations. We went from 1 below to 2 above. That's why I could use the empirical rule. Empirical rule is quick, it's easy, tells us a lot of important information, helps us see things, but it only works with an integer number of standard deviations. It's a good check, though, as well. So I did put this note here. By z-scores, you should have 81.9%. So if you use the calculator, 81.9%. Okay.
Are you talking about
On B, yeah. Use z-scores, you would have gotten 81.9.
what I got is the notes that you put, isn't it just a history of this one? Why is it 81?
No, Raina, if you do it by empirical rule, it's 81.5%. If you did z-scores on the calculator, it's 81.9%. Right, but you need to be clear on the difference between the two. So like when I say z-scores right here, I mean using the calculator. Yeah. Okay, C. So right away, like if you've drawn it out, we do need to recognize 140.5, is that an integer number of standard deviations? No. Notice it was an ugly sketch, that's not what I would actually do. But once again, I got to a new problem here. And what did I do?
You drew it out.
I drew it out. I drew my normal distribution. Every time, the more you practice it, the more natural the instinct is. It's one of those things that, trying to think. Emerson, the more you play, what instrument do you play? Clarinet. The more you play clarinet, the more you practice, the more instinctive it becomes, right? Okay. Soccer. The more you play soccer, the more natural the ball feels at your feet, right? You don't have to think about it as much. The more you practice drawing the normal distribution, you don't have to think about it, you just do it. I see a normal distribution, I draw the normal curve. Every time. Okay? Practice, practice, practice the right way. Because I will also say this, one of the big things that I haven't told you yet is when we get to inferential statistics and probability ideas, if you don't draw the normal curve, you have to do a whole bunch of extra work to show that you understand what's going on. If you just draw the normal distribution with your mean and your standard deviation, or your mean and the z-score, you're good. It's an easy way to get that evidence. Alright? So how did I get that negative 1.6 repeating again? The value of 140.5 minus the mean of 153 divided by 2. Okay, and so I think it came out to be negative 5/3 when it's simplified, or negative 1.6 repeating. Now I do want to remind you of this. Can you find a z-score even if it's not normal?
Yes.
Because what is a z-score?
It's
The number of, it's distance, but it's the number of standard deviations,
From the mean.
not just from, above or below. Okay, so that's what a z-score is. It's just the number of standard deviations either above or below the mean. And when I have a normal distribution, I can calculate some area. Okay, we've got to combine those two ideas. So a z-score is just how many standard deviations above or below the mean. And if I have a normal distribution, I can use the calculator to find that area. So it does just say above 140.5. So I'm going to go to that negative 1.6 repeating. So here, what is that going to be? Or what do I need to do once I have marked that?
Shade in the
So shade to the right. So when I go to my calculator, what is that negative 1.6 repeating going to be? That is the...
That's the value.
Okay, how about this? Pick up your calculator, pick up TI Inspire. Okay, if you don't have a TI Inspire yet, get one in hand. Go to a calculator page. Go to normal CDF. Right?
I can got you. Thanks.
So remember, normal CDF is that cumulative density function, finding the area. What is it asking for on that?
The lower and upper bound.
Oh, the lower and upper bound. That negative 1.6 repeating is the lower bound. Isn't that the lowest part of my shaded region?
Right.
Okay, this is again why we draw this out. When I draw it out, I can see that that negative 5/3, that negative 1.6 repeating
is the lower bound.
is my lower bound. Again, draw the normal distribution. When I shade it, I see that that's my lower bound. I don't make mistakes this way, it's clear. So what's the upper bound?
It's infinity.
It is infinity, right? So, does anyone remember what you can put as the upper bound since we can't type it?
We just get like 100, 1,000.
You could do, so 100, you could do 1,000. It's going to sound bizarre, but you know what? You could even put just
10.
10. You could probably put 5 and get a close enough answer, because remember, 99.7% of the data is within 3 standard deviations. You don't have to go much higher. But pick one of those, put in your upper bound.
Is it like one of those things where it never touches with the number line?
Yeah, it's an asymptote,
Yeah.
horizontal asymptote.
What's that? Right?
Do you think about a rational function?
Yeah.
There's also exponentials and logarithms that have asymptotes as well. Okay,
What'd you put on that for the
I would put 100 probably. You could put 1,000. As long as it's significantly bigger than 3, you're good. So what value do we get out of that? What area specifically?
95%,
Be careful.
or 0.95 of the.
proportion?
The proportion. A couple of us messed this up and we need to be careful about this. Does this ask for a percent? No, it asks for a proportion. When it asks for a proportion, please make that note to yourself. A proportion means that decimal, that area under the curve, not a percent. Okay? They will clarify the difference. And the reason why that matters is when we start talking about probability. So the probability of an event versus the percent of all test takers. Okay, that's why that matters. Okay, Andrew, you good? You just look like you're thinking real hard. Okay. Charlie, you good with that? You also look like you're thinking real hard about it. Okay. We good? Any questions? We ready to learn from this and do better next time?
Yes, sir.
Okay.
Wait, okay.
Before
Yes.
we start conversation.
And you can run to the restroom, but I'm starting.
How did the question tell us that how did we know from the question that we need to find an area?
Proportion.
Um,
The proportion means that decimal, that area under the curve. And notice in B, it specifically asks for a percent. That's how I knew.
Okay.
Yes, Raina?
What I'm just a little bit confused about the calculator, one more thing is just when you do inverse normal, you put the proportion instead of percentage in the area, right? If
Correct.
It's 90% of.
Because we'll get to there in a second, but hold on to that, yes. So proportion of GRE, so I'm looking for that decimal, that area. Again, drawing it out, I see that I have bounds, I need the area. Yes, Sophie?
You say I want to use 4 decimal points, what do we have to use?
That's a good question. So, one, it's going to matter when we get to probability. You always report probability 4 decimal points. 2, if you cut off the number of decimals too soon, then it's going to throw answers off a little bit. Like I could be wrong, but I think someone did a negative 1.7 for their z-score, and so they got a little bit off of that 0.9522. So I would always do for a z-score at least 2 decimal places, but I would even go beyond that to put it in the calculator. By the way, that's one of the reasons why I like this fraction. Okay, so finding the fraction version of it is really powerful as well, to make sure that you don't have to worry about that. But then, final detail on that, Sophie, do you remember how I showed you all that table the other day that we had to use back in the day when I took AP stats? Yeah. The area on there was always reported in 4 decimal places, so that's kind of like the standard that's expected on the AP exam. So, z-scores at least 2 decimal places. I would do more to be more precise. Area or proportions, they want 4 decimal places. At least 3, but probably 4. I think it was still calculus, you had to do 3, right?
Decimals?
Yes.
Yeah,
Truncated
but
at 3.
stats was always 4.
Yeah. Yes, right.
So if this time it was the infinity was like the right boundary.
Yes.
Side. If
Was
it's
it
the left
never-
side, if it's left side in the calculator, should have just put 0.
No, because 0's in the center.
No.
What would it be on the left side?
Negative 100.
Negative 100. It'd be technically negative infinity, but negative 100 is enough. I think it already puts, though, if you look at it, when it naturally comes up, if it's to that negative infinity, they do negative 9e 999.
Yeah.
So it's negative 9 times 10 to the 999th. So that's wicked negative. Yeah, wicked negative. Alright, we gotta get going. So D. Alright, I got a normal distribution, so what am I gonna do?
Draw it
I'm
out.
gonna draw it out. I know, it's crazy. Drawing. Okay, so there's my normal curve. 0, 1, 2. And now one of the things I think that threw some of us off on this one is that 9%. Where was that 9% located? It was on the right side. It was the top 9%, right? But on the calculator, we always have to put, so like the 9% is over here. On the calculator, the TI Inspire, you always have to put what is to the left. So notice how I noted it here as the 91st percentile. Okay? The one tricky part, so pause on this, and I need to focus on this, I'm going to talk about this in a second. The one tricky part here is knowing where to kind of draw the boundary, because I don't have the boundary yet. But this is where empirical rule is really, really, really useful, okay? At 1 standard deviation above the mean, that's 34%, right? So what percentile was 1 standard deviation above the mean? It was the 84th percentile, right?
Right.
Okay? The second standard deviation above the mean, remember that's 47.5%, right? Plus that 50, so right here is 97.5, or 97th percentile, I should say. So this top 9%, which is the 91st percentile, that z-score, that boundary, has to go somewhere in here.
Wait, where the 84th percentile come from?
So if we're at 1 standard deviation above the mean, 68, right? But half of 68 for here is 34% of the data. And what's always less than the mean?
50.
So I'm able to quickly see what my percentiles are if it's a normal distribution. That's why I said this was the 97th, because from here to here is half of that 95. Does that make sense? Okay, so I just know that my z-score has to be somewhere in here. Now, notice, do I have this boundary?
No.
No.
So you get the value and subtract it from one?
No.
It gives you that,
So what you want is, well, so there is, sorry, I'm trying to think. It depends on what you mean by the value and subtract by 1. 1 minus 0.09 or 100% minus 9% gave me 91%. But remember, that is an area. That's this area, which is 0.91.
Yeah.
So notice I'm getting an area from my 91st percentile. Now when I pick up that calculator, bear with me for a second. I know some of us are like, Mr. Kenny, this is dumb, but trust me. Pick up the calculator, hit menu, okay? Go to 5 probability or 6 statistics, then go to your distributions. Please hit normal CDF for me, okay? So when you look at normal CDF, what is normal CDF asking for?
Lower and
Lower
upper
bound.
bound.
The lower and upper bounds. Do I have that boundary? No, that's how I know I'm not doing a normal CDF.
Right.
Now I'll go back through it and go to inverse normal,
Okay, I'm gonna do that one.
okay? Okay, inverse normal, what does it ask for?
The area.
And what do we have?
The
The
area.
area. Remember, the inverse normal is what allows us to go from the area to the z-score, because remember, it's an inverse.
Right.
The normal direction is we go from a boundary to the area, but if I have an area and I want to go to the boundary, that is the
Inverse.
inverse. That's the idea. So this is my normal function here. Think about it that way. That's my function. I normally go from a boundary to an area. But if I have an area and I want to go to a boundary, my inputs and outputs have transposed, they have switched, and then I need an inverse. Okay? And so what z-score did that give me?
1.34.
Did anybody get negative 1.34 here?
No.
You just did the opposite. Okay? Do you know why that works? Okay? So, what we have there with Madeline is you got negative 1.34, right? Because you put 0.09 in. Well, isn't there symmetry here? So when you got that negative 1.34, you must have realized, hey, that can't be right because that's below the mean, and so you just tried the positive 1.34?
I think I did both, because I was.
And so you did the calculations from both directions?
Yeah, I think I did because I didn't know
Yeah.
if I put
So-
whatever one.
What Madeline did can work. It's not the preferred way, but notice if you do 0.09, that only gives you this tail, right? And that is the complement, which is the opposite side of what you wanted. You wanted the top 9%, so it had to be a positive 1.34. That is not the way I would go about it, but it can work if you realize that error. Right? If you're in the top 9%, shouldn't your z-score be a positive value? Because you're above the mean. So that's something to remember. Again, location. A positive z-score is above the mean, a negative z-score is below the mean. Keep that logical side always there. And then from here, solve your equation. I think I saw someone say about 164. Don't do that. Just do the calculations. Let the number be what it is. 163.06. Please notice it's not a percent. A GRE just has a score. I think someone put a percent there, but it's not a percent. It's dumb. It's like a 140 to 170 is the way the GRE is set up. Right.
We don't tell you flat score.
No. Like, yeah, you don't get a raw score. The scaled score that they report is on the quantitative reasoning, you get from a 140 to a 170. And on the verbal reasoning, you can get from a 140 to a 170. So the score for the overall test is 280 to 340, which is dumb. Same. It's kind of like with the SAT, though. It goes from 200 to 800. I don't know. Makes zero sense to me. But someone did something sometime somewhere. Okay. Please do remember, you're solving this equation, but you can also just use the calculator to do a numerical solve. Okay? We need to quickly go over some free response questions that you might have. What questions do you have that are through this DYU at this point?
Is it?
Phoebe? Okay.
I do have a lot, so I'll just ask you after.
Okay, sounds good. All right. So, free response questions. I've already given you the answer key. And because everyone did the questions, I know, right, Ethan?
Probably.
Probably. And-
I did up to this point.
Oh,
That's great, Star. Hey, so I got stuck at you though.
Yeah, I did.
okay, so let's look here at 2021 first. 2021 is an important one because it's more modern, right? It's something that we should be expecting to see something similar to in the future. Should look similar to a DYU question that we had.
Oh, wait, I think I did
2021.
Okay, so there, I assigned 2021 and 2017. 2021 is the one that looks a little janky. Okay,
Oh.
flip it over. We did 2016 yesterday.
Oh, that's.
We went over it yesterday. We didn't do it yesterday. All right, right here. So, what does it ask for?
The 5-number summary.
5-number summary. Could you put all those data points into your calculator?
Yes.
Sure. Could that tell you the 5-number summary?
Yes.
Yes. But you got 13 minutes per question.
So don't do that.
So I wouldn't. What should we do to find that 5-number summary? Say it louder.
50.
Okay, so 50 divided by 2, because there's 50 patients, splits it as 25 and 25, okay? What else do I need to do?
25th of the data.
I'm going to do one more thing first. You can do that. I'm going to do something different. Yeah, I'm going to split that 25, right? Because I still need my first quartile and my third quartile. So 12, 1 is my first quartile, and 12, okay? So my median's in between here. 12, 1, and 12. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my first quartile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right in between those two is my median. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's my third quartile. Just counted it out. I think that's right.
6, 7, 8.
Yep. So that splits it every 12-ish. Okay. So, 5-number summary. I got to be quick with this. What are the 5 numbers in my 5-number summary? So the minimum is 5.
Q1 is 6.
Q1 is 6.
Median is 7.
Median is 7.
Q3 is 8. Maximum is 21.
And max is 21. So bad. Okay. Yeah, wicked humble. I know. All right. 5-number summary. We good? Hopefully.
Oh, yes.
Shout out if you got questions. So that's something we want to make sure we are able to get right on the AP exam. I don't think there was a 5-number summary question, 5-number summary question last year, which probably means it'll be upcoming, or even last 2 years, so it probably will be this year at the latest next year. That's kind of how they work as they go through cycles. B, consider 2 rules for identifying outliers. This is actually the reason why I taught you about the standard deviation rule. All right, using method A, determine any data points that are potential outliers in the distribution. So how are we gonna do that? Say again?
Why do they ask determine potential outliers, so don't you do that before you measure? Don't you determine what the potential?
Yeah, you should really say
Determine outliers.
determine outliers in this one. Yeah, I don't like that language. It should say maybe determine if any potential outliers are outliers. I don't know. I don't like that, but yeah, 1.5 times IQR, so 1.5 times
Through 2.
2. There's my IQR. Is equal to? Okay, so Q1 minus, and I would even just write this out each time. 6 minus 3 is 3. That's my lower fence. We got anything below that? Nope. So no lower. Q3 plus 1.5
Is 11.
times I think. Thank you, Star. That was impressive. How'd you do that?
I actually did the word.
That's wild. So do we have any upper outliers?
Yes.
2.
We got 2. We've got 12 and 21, right? Which naturally right away we should think, hey, 21 is probably an outlier. 12 may have not been as much on our radar. Yes,
Am
Madeline?
I gonna get in trouble if I don't do the lower one, since I know that?
Yeah, do them both. Yeah.
Okay.
So you can say, I can tell right away, but you gotta remember your job as a AP Stat student is to clearly communicate to the reader that you don't know it, so you gotta show some work for it. Yeah, that's a good question though. Raina, then Ian.
What we have learned was just, this is a method to determine outliers.
Right.
And number C is just, we're gonna get there, but I just, know the difference and how it's going to.
We're gonna talk about it.
interact with can be more, yeah.
Okay, why do we do 1.5 times 2?
Huh? You can just say IQR.
I know, but like, why are we multiplying it times 1.5?
Because that's
Because that's the
IQR rule is 1.5 times the IQR. Do you not remember
I
that
thought
one?
it was, we had for the upper and lower fence.
Yeah,
Yeah.
the lower fence, you start at the first quartile and you subtract 1.5 times the IQR. That's my lower fence. My upper fence is the third quartile plus 1.5 times the IQR.
Yeah.
So there's my lower fence. So 6 minus 3, 8 plus 3. What are you confused by? You're agreeing with everything I just did.
I was confused, like, why you multiply it? Like,
I
I'm
had,
just used to doing the upper and lower fence.
that's what I did.
Not like the top part.
You talking about this?
Yeah.
I just went ahead and did this.
And they both require the IQR.
1.5 times the IQR. Isn't, what's 1.5 times 2?
Oh.
You can do it as a separate step or not. You could have done. You could have done it like that.
Oh, forgive me, I just
did it separately because I knew I was going to have to do it twice.
my eyes just like confused.
Does that make sense now?
Oh, yeah.
Okay. You can do it that way. You don't have to do it as a separate step like this, if that's what you're concerned about. Okay, second method. Mean length of stay for a sample is 7.42 days and a standard deviation of 2.37 days. Using method B, determining data points that are potential outliers. So the second method is why I taught you all the 2 standard deviations rules. So the mean is 7.42
Plus minus.
plus or minus.
Standard, 2 times standard deviation.
All right, so what's my lower fence in this case?
1.16.
Lower fence.
Oh, 5.68.
That's 7.42 minus 4.74. Hold on. Minus first. You're doing, I asked for lower fence, not upper fence. There we go, 2.68. There we go. Do we have any data values below that 2.68? Nope.
No.
So no lower outliers. And then y'all are talking about the upper one, right? It was 12 point something? 12.16. That's my upper fence. Do I have any data values this time?
Yes, 1.
Just one?
Just one.
Just 21, right? So there's one upper outlier at 21. So C here, why would method A identify more outliers than method B? Well, why do you think? This is an important statistical concept here.
Because the skew causes it to follow the.
It was part of it. Yes, you have a rubric, scoring guideline to look at. Yes, madam.
The median of resistance.
So, yeah, remember, is that median, and it's not even just the outliers, is the median, the quartiles, going to be affected by that skewness?
Not as much.
Not as much, right? How about the mean and the standard deviation? Very much, right? So notice, because it's skewed like this, because it's so spread out, there's going to be more spread incorporated in the standard deviation than there is in the IQR. For that reason, notice this upper fence was past that 12. And so it's really this heavy outlier, right? So we used to in stats talk about outliers and heavy outliers, I think. This 21 is such a heavy outlier that it causes that upper fence from the mean to be higher. What did it actually say in the rubric though that I gave you?
Oh, man.
Oh man, reading, it's tough, Mr. Canny.
It is.
4,000 less.
I don't know what it is.
It's 2021.
2021.
Sorry, Madeline, what were you saying?
The 4,000 IQR or less and it took 3,000 strongest distributions in the mean standard deviation.
Okay. So, and notice like we have all this up here that you had to hit. So you had to hit these two following components. The mean is pulled more towards the extreme values in the longer right tail, right? That's that idea that the mean is more heavily affected.
Non-resistant.
It's less resistant. Or the ratio of the standard deviation, you don't need to be worried about that ratio part. We would not have talked about that at all. But the mean is pulled towards the right. It wasn't the mean to the right of my median even, causing more spread there. And then number two, we need to recognize that we need to provide an explanation that links the effects of skewness on an increasability of method A. Ooh, I like the wording of that. Notice, again, it's the idea that does the skewness affect A?
No.
No, method A, it doesn't, because we're talking about the IQR. So method A is able to detect those outliers better, is the wording that they're using there. And this is kind of what I was going to argue. The larger increase in the standard deviation relative to the IQR results in a greater increase in the range of non-outlier values, right? Or you could say that there's a smaller range for the IQR. So we need to recognize that the IQR is better able to identify outliers, which is why they used to not do 2 times the standard deviation. Yes, Raina?
Just a vocabulary question. When you said less resistant, isn't it also supposed to say, standard deviation and the mean is
We
not
really
resistant?
should just say standard deviation and mean are not resistant, whereas the median and IQR are resistant. So not less or more, just
It's that-
median and IQR are not resistant, are resistant, mean and standard deviation are not resistant. Yes, Star?
Do we have any like newer questions, like from last year?
Yes, and we'll use them sometimes, but there wasn't a good question like this from last year. So usually they'll do like one exploring univariate data or one bivariate data. Or maybe the reason why I didn't choose one from last year is because it incorporates ideas beyond what we've studied. So like, there's multiple pieces like this, and so like I have to choose questions where we've covered everything that's in the question.
Understood.
Okay, I'm gonna move quicker through 2017 because we gotta go. We only have 5 minutes before we come back and do bivariate data after lunch. But really quickly here, for chemical Z, describe how the percents found in the pieces of pottery are similar and how they differ. What are they asking us to do in A? They're asking us to cuss
No.
in context. But I will point this out, guys. We have among the 3 sites. So which one was C? Or Z? Yeah.
It's the third one.
It's this one right here. Okay.
No, wait,
No,
it's
see,
always
that's
just the
right.
third.
I got you. So here,
Correction.
here, and here. Okay. The one thing you got to remember is we're now looking at 3 distributions, and they want us to what?
Cussing context.
There's one more thing.
Different
And
similarity.
compare.
And
So we need to compare, right? We need to cuss in context and compare. We do have box plots, so I will point out, we don't actually need to talk about,
The
outliers too much. They're mostly asking us to compare. So when I look at these distributions, first off, I need to get some context in there, right? So for chemical Z, the percent found in the pottery. Notice I just took the context directly from that question, right? Like I didn't do anything fancy. Okay, so what do I need to talk about the percent found in the pottery?
The center.
The center. So what about the centers?
It's roughly the same.
So it's roughly the same. So the median
Of the each data
It's roughly
is
roughly same.
this is roughly the same. At about 7%. Okay, what else should we say?
The range is different.
So not just differing, site 3 has what kind of range?
Largest.
So the largest range. Notice does site 3 have the largest IQR?
Yeah, no.
Those IQRs are about the same.
But
Okay, so I would focus on the range. Site 3 has the largest range, and site 2 has the
worst
smallest
that makes sense.
range. By explicitly saying which one's largest and which one's smallest, I don't have to talk about site 1. But I have directly compared the center and the
Range. Spread.
range, which is my spread, right? What else do I still need to talk about?
The unusual
Spread.
Spread,
Size.
right? So
Spread.
all 3 distributions are unimodal, right? Thank you. We can't determine unimodal. We can only say they're what? Roughly symmetric or approximately symmetric.
Hey,
With or without outliers?
Without, because of the nuts.
With no dots, yeah. You don't have to hit all those things I remember from this rubric, but that is good to note. Notice I explicitly identified roughly what the median was, that the medians were all the same. You probably should or could find what the actual ranges are, but just identifying what was the largest and smallest range was enough. Yeah.
It says just to, because you're in similarity and difference, I just said, medians are similar and they said it's similar to the range is different. And with it-
Look at the rubric and see what they say there. At lunch or maybe something, because it'll tell you explicitly if you need the numbers or not. Let's see, B2, supposing analysis of the clay reveals that the sum of the percents of the 3 chemicals X, Y, and Z is 20.5%. Based on the box plot, which site, 1, 2, or 3, is the most likely site where the piece of pottery originated? Well, 20.5%, I'm probably going to go with site 3. I'm just looking, I think. Hold on. What was it? 20.5%? So 6, 13. That's about, if I just look at the medians, isn't that about 20%?
Oh, that's okay.
But if you also look at the minimums, the minimum here is 6, the minimum here is 4, and the minimum here is 13. That minimum is 23% already. So the maximum here is too much. So you had to look at it that way. Yes, you can heat up the microwave. So that minimum is 6, that minimum is 4, that minimum, oh, that's going to be 11. I know. It's still a minimum of 21%.
Look at my stack of tassels.
You see how the minimum is 21% there? Wednesday versus Thursday for the test. Who wants Wednesday? Star's the only one feeling pressure because it does not say Wednesday.
No, I
So who wants Thursday?
Oh wait, I thought, wait. I thought it was Wednesday or Tuesday.
Thursday.
Today's Tuesday, dog.
Wait,
Wednesday.
what is this option?
Wednesday versus Thursday for the test.
Thursday.
So, who wants Wednesday? Who wants Thursday?
Bro,
Outline.
y'all
Alright,
Kinsey
cool.
also wants Thursday.
Cool. So, Thursday it is. Just remember, that means basically only bivariate data. I will give y'all one free response question to look at that we'll talk about as the bell ringer tomorrow, but that's it. That means you actually need to do it. Actually, let me go ahead and tell you, I guess, which one then.
Oh, sorry.
Do what?
The one free response question that I would do if I were you. Okay, if I were you, I would do the 2010 Form B, number 1. That's at least the one we'll go over tomorrow. But if I were you, I would also practice the 2019 number 1, where they actually have you make a box plot. And I will give you the answer key somewhere, either in person or on Schoology. I'll let you know, tell you. Huh? Okay. I'll give you the answer key for both of those, but the one that we're going to go over in class is the 2010 Form B number 1. So tomorrow, to start class, 2010 Form B number 1 is the one we're going to do, but I would definitely do the 2019 one to make sure we understand how to construct a box plot, or maybe create a box plot for the one we just looked at. All right, right here. So if you look at the rubric, what I will say, and so the reason why I don't use this question for your actual test, because there's a lot of good stuff in it, is actually, this B2 or B1 right here, they require that you actually check the minimum and the maximum to realize what it could be. I would have only thought to look at the medians, right? But if we're trying to find 20.5%, 6 plus 7 plus 7 is 20%. That's pretty close to 20.5.
Alright.
They asked us here, suppose an analysis of the clay reveals that the sum of the percents of X, Y, and Z is 20.5%. Based on the box plots, which site is the most likely site where the piece of pottery originated? And so when I did this one, looked at the medians and summed those medians together, noting that the sum of these medians is only, what's that, 6, 7, 13, 16? That's nowhere close to that 20.5%. The sum of these medians, 7 plus 7 plus 13 is 27%, so nowhere close to that 20.5%. I felt like statistically, that should have been good enough evidence. They wanted you to look at the minimum and the maximum. So like the minimum here is 21%, which is above that 20.5. The maximum here is 19%, which is below the 20.5%. So that's why it had to be site 3 for B1. Yes, Emerson?
Sorry, this is about the first use. Do you want the entire 2019?
I said 2010 Form B. Oh, it's the ones I've already given you, not the entire 2019 test.
No, you said 2019, what you were saying? Did you mean
I said
that?
2010 Form B is the one we're going to go over in class tomorrow. If I were you, I would do the 2019 number 1 because it has you constructing a box plot, which is an important thing to make sure you know how to do.
Okay.
And I'll give you the scoring guideline for that as well, but we're just not going to go over it in class. That way you can check yourself right now.
I happen to just say site 3 because when I did the box plot and figure most is over like I don't know why, but I would be just sure.
But you have to look at numerical values, statistics. So looking at the medians or looking at the max and the min, things like that, to justify your response. Notice again, I gave you the solution or the scoring guidelines, and they required that. B2, suppose only one chemical could be analyzed in the piece of pottery. Which chemical, X, Y, or Z, should be the most useful in identifying the site that it came from? Now, I want to point this out just right away. We should know it's not Z. Does anyone know why we would not want to use chemical Z based on stuff we've already done?
Too much variance.
Because they're too close together.
What do you mean by that?
You need to have more variability.
You need more variability. There's something else I'm looking for.
Would you need like a different like
you need different centers, right? Like, isn't the median the same for chemical Z all the way across? So that wouldn't help me really know which site it came from if they have roughly the same center. That should get us started thinking, okay, so which of those chemicals would be the best to look at to know which site it came from? Y. Notice the Y does not overlap at all in the box plots. So if I know a certain percent, I would know which site it came from, right? So chemical Y would be the best there. So when you're comparing distributions, and this is why I did want to talk about this question, when you're comparing distributions, you need to think about the centers. How do the measures of center compare to each other? When you're looking at the, and then you look at the spread as well, how do those compare to each other to help you make statistical decisions? One thing I do want to leave off with is I do want to point out when we look at these free response questions, don't forget this does go all the way back to the categorical data. One thing to be aware of is that we will do a lot more with categorical data with two-way tables in our probability unit. And we haven't seen any with normal distribution. You need to know normal distribution because they'll all show up on multiple choice, but pure normal distribution doesn't show up a ton on the AP exam. It is involved in other concepts. Same thing with categorical data. It's involved in a lot of probability stuff. It will definitely be in the multiple choice, so you have to understand all those concepts well. But remember, it goes all the way back to that first proficiency scale for this unit. And so we got to keep that in mind as you're preparing for that test. All right, we got to get going though. Let's see. Yep, let's grab some candy. So we're starting our next unit. And I'll pass that out afterwards. Here we go. This is what I need. So I have a box of Starburst here. And someone's going to get to eat them at some point. And here's what we're going to do with these Starbursts. You're going to use a claw-like motion. You can move Starbursts around a little bit, but you have to go straight down and straight up. You grab as many Starbursts as you can. Pull it out, and then you count it. We're just going to look at the distribution, what it looks like when we grab our Starburst. Now, if I want to find a true expected value for this classroom, what do I need to do?
Find the average.
Find the number of people in the class.
14, but there's something, let me ask this a different way. 14 is not a ton, but let's say I didn't want to get data from all 14 people. I need to randomize, don't I? Okay, so remember these numbers when I say them in a second. Does anyone see my green attendance book? Yeah, that's it, thank you. Alright, normally I don't have to tell students these because they know them because of the cell phone pocket deal, but Lorelei, number 1, Madeline, number 3, no, we'll do it this way. Madeline, number 2, Leah, number 3, Dixie, number 4, Andrew, number 5, Kinsey, number 6, Emerson, number 7, Sophie, number 8, Ethan, number 9, Ian, 10, Star, 11, Raina, 12, Phoebe, 13, and Charlie, 14. Okay?
I'm 11.
Thank goodness you're not 6 or 7.
No, it isn't. Yeah.
Emerson, we are such a power to over
So we're gonna win.
president.
That's it. That's what I heard.
I guess they call it.
All right. So how many do you think I should generate? How many people?
7.
13.
Okay, so half. 13. I might as well do all 14 at that point.
Yep, there's only 13 people in here.
There's
Wait, sorry, I missed her.
I would say we got 14. Let's see. I need probability.
What if we get a census?
We could, but that defeats the purpose of me going through the idea of a random integer. So 1 to 14, notice, once again, hey, remember, if I want to randomly generate, I need to assign everybody a
Treatment.
unique identifier. Have I assigned everyone a unique identifier?
Yes.
Yes. Now I am going to randomly generate with a random number generator. And then I'm going to select
The
those individuals. Okay. So, 14, Charlie, you're up first. Where did I put the candy? Here we go. So, Charlie's gonna come up. Let's just do it right here because we have a blank space. Actually, we'll do it right here. Blank space. Go grab your candy, pull it out, let us know how many you grab. Okay. After Charlie, 13. Who was that? Phoebe.
Have you seen it?
Bias.
Okay.
This is right.
And we
Yes.
just take the candy with us?
No, put it back in. Once you collect it, we'll let everybody have some candy later. So grab as many as you can. All right. Who was 3? So count how many you got.
Oh, is it?
I would say I think so. All right. So you count how many. Oh, Charlie, how many did you grab?
18.
18.
And the next time it's gonna be 8.
Okay. Phoebe, how many did you grab?
Well, I used a call, but what if you said call it?
Yeah, you had to use a call. That's the whole thing.
Fine.
All right.
I actually grabbed it.
Leah.
I'm counting.
Okay, you're good.
Jeez.
I know. Who's number 8? Sophie.
Oh, so close.
I had 20.
Nice. All right. After Sophie is number 6.
Yes! Oh, me!
Kids, you got excited?
Yes.
Okay.
That man.
Okay, I got 9.
You got 9.
Outlier, outlier.
Okay.
Hold on.
All right. Number 11. Star. Yeah, real height.
6, 7, 8, 9, 10, 11, 12, 13, 14. I got 14.
Who's number 1?
Me.
Go for it.
How does Star pick up that news?
Oh my god.
Wait, Sophie, how many did you get?
I don't have any more of that candy. I need to get some more so I can.
My sleeve got
Star, how hard is it to count, bro?
He's got a lot. He's got a lot.
It's so strenuous.
Kinsey, how many did you grab?
I got, wait,
14. 14.
I got 14.
Star?
I'm glad I yelled it out.
33.
What?
Oh.
33.
All right.
Ratty.
One, that is unnecessary. All right. So, let's do this.
Star's the outlier.
Let's do one more just for kicks and giggles. Number 5.
Oh, so it's gonna be hungry.
I got 12.
It's okay.
12.
No worries.
Man,
just not know what number we are?
It's okay, I'll die.
Most people I have.
I'll play it.
This is not very sigma.
Thank
Okay.
you.
What?
All right. Now I'm gonna do one more. Just for, no, we already did 14. We already did 3. Who was 12? You're the last one.
12!
It's okay, we'll starve you. It's okay.
That's like almost 6 of us.
Alright, so at this point, what I need everyone to do is I need you to enter your data. So, do people, do candy. Everyone's going to need to enter this data into a list and spreadsheets page so you can practice going through calculations.
Uh-oh.
So, put people, put candy. We got Charlie, we got Phoebe, Leah,
25. Oh my God,
Sophie,
that's
and
all
Kinsey.
of me.
Hey, this not being in like the keyboard order is making it hard.
Well, it's a weird alphabetical order, so eventually it gets easier.
25.
25.
I'm kicking my foot.
Wait.
And Andrew, how many?
Wait, hold on. Wait.
How do I go to column B?
Never mind. You guys are not as
Charlie.
big as me.
Baby.
I spoke
Literally, you are the tallest person in this room. I don't.
Andrew, why are you so good?
Alright. Do we have through number 5?
No, sir, no,
I'm
sir.
about to write this on the board. Oh my gosh.
It's the keyboard's fault.
Yeah, that's what it
If I was
is.
on my phone.
Actually, yeah, it took me a long time. What's a
Yeah.
phone board?
Char. What's that?
Yeah, I don't know. It's a vlog.
If you're from
What?
Thank you.
Bless you.
You're good.
Thank you.
Sophie, really 9?
Yes.
S-O.
Can we do it?
Sure, go for it. Let's, I don't know if it's gonna get much better, let's see.
Does that cause variance? I feel like that's illegal.
You mean, does it skew the data? Does
Yeah.
it cause
Can I
bias?
actually do it?
Yeah, go for it.
Wait, who's
Really
number
bad.
5? That's really weird.
Me. Me.
I mean, not T.
This keyboard is messing me up. Hey.
See?
Oh wait, what did I do? Oh shoot.
Never done this before.
Wait,
What?
where's the
Me, I was 14.
star?
Who was?
I was 14.
Yeah, I have it up here.
I got 18.
Oh, that's.
It's me, yeah, it was better.
Star 33.
What?
Oh, never mind.
Alright,
Oh, we're all lying.
please enter that data.
Arlington Max 10.
And what I want you to do with that data is I want you to analyze it.
Oh, sir, you're an outlier.
Thank you. I tried.
We don't know that he's an outlier.
Oh.
He's an approximate.
Alright guys, no, you can't say approximate outlier. I need you to analyze this data once you get that data in. Work with your small group on analyzing that data. Let's write our analysis on vertical surfaces.
We only did 9.
Are talking about this data, please make sure, at least for the AP exam, write this as a couple of sentences, as a paragraph, as the majority of us are doing. I do like what this group over here did, where they literally wrote out cuss. That is something I highly recommend, because then you can just quickly go and like just check it off. Or what I might even, and they wrote out the whole cuss, but I might just literally write out the letters cuss, context, and then once you hit something, check it off. Right? So once you hit it, check it off to make sure you hit all those features. Just take the time, it helps, I promise you. The ones who do that are always successful on this piece. Alright, so I do like over successful? I don't know what I said. There is one potential outlier at 33. That'd be totally fine, right? However, okay, if you actually do the calculations, or if you just look at the box plot, was there an outlier?
No. No outlier.
Right? So if I change it to a box plot, we can clearly see no outliers here, but it is skewed to the right. Okay, here's my question for you guys. At least based on the data we have currently collected, if I were to have one more person, let's see, who was someone that was never picked? Madeline, you never got to go, right?
Yeah.
If Madeline was to go now, how many starbursts would you expect her to grab?
About
Like 18?
Like about 17.
20.
18. We have the median.
So 18? Okay, so you're talking about the median 18. You said what again there, Madeline?
I did 21,
You
because I
said-
think I can do it.
Because you think you can do 21? But based on the data, how many would you expect?
About 18.
I would say either 18 or there's another
The
option.
mean.
Or
20.
20.
20.
Okay? Notice I will point out, why is the mean larger than the median?
Because it's
Right, okay, so we want to recognize that mean was pulled to the right, was pulled towards the 20 because it was skewed right. Now, I'm going to hold on to, I'm going to focus on that 20 for now. I'll explain why later. So, we would expect Madeline to be able to grab 20. Madeline,
Oh, no.
go grab some candy.
Go grab some candy.
Go Madeline.
What about the compound variables?
Bring us home some food.
It's not an experiment. What if she did
Wait,
sequel
actually-
enough?
That did not sound like 20. That sounded like 21.
Probably 6 or
Oh, she got exactly how many?
20.
20.
Whoa,
Okay.
how did she do that?
Alright, that's crazy. Alright, so here's my question though, okay? But Star got how many?
33.
Because he's big.
Wait, so are you saying that there's another variable that could explain how many he's able to grab?
Yes. Variability.
Okay, so so you first just said he's big, right? So like, could his height correspond to?
A taller height means a
Hold on,
bigger.
So height. I want us to think about this. So what we're saying is,
I'm not that tall, but
hold on, here. Height is predicting his amount of candy, right? Okay. I did hear someone say desire is impacting how many candies he can grab. What else can you explain? Hand size, okay. When I say desire, I really
Overall,
mean
he's biased, so he
competitiveness.
should be eliminated.
I feel like, because I'll be honest, I don't care about that.
She's like, eating.
Oh, is that what it is? So, well, I'll point this out. I'm not saying that Madeline's the smallest girl in the world, but she's still got more than a whole bunch of us. Any idea why Madeline got 20 when a whole bunch of us got less than 20?
She was determined to get 20.
She was determined to get 20. I don't know if y'all saw Madeline going in, but she was like, I'm gonna get as many as possible, right? Can competitiveness explain how much candy you're grabbing?
Probably, yeah.
I'm gonna go on a limb and say Sophie just didn't care when she originally did 9. Is that accurate? So does competitiveness factor into this? Yes, okay. Hand size, does that impact maybe the amount of candy you can grab?
Yeah, most prevalent.
Okay, so
Why is there small?
eyes and ears here though. So what am I gonna call these variables?
Confounding.
Not confounds.
Potential bias.
Nope, not potential bias. Nope, not potential confounds.
Wait, what's it start with?
Starts with E, it's something we've studied before.
Extrinsic.
Not extraneous, good thoughts.
Extrinsic variable.
Intrinsic values.
These things are predicting or explaining.
Explanatory.
Oh, this might be my explanatory variables. The amount of candy grabbed is my response variable. So, okay, there we go. Okay. So, notice how many variables do we now have at play?
2.
Oh, yeah.
Well, there's 3 explanatory, but like if I'm just looking at one set of data, how many variables do we have? 2, right? We have an explanatory or an independent variable, and we have a response variable, which is also our dependent variable. So, we now need to collect some new data, don't we?
Yes.
So which of these do you think, well first off, we can't really measure desire, right? Which of these 2 then do you think are the best,
Hand size.
hand size might predict the best?
Desire.
Probably desire, but so I'll say this, I don't think that anyone's desire was greater than Madeline's, but she definitely didn't grab as many as you did, right Star? Star's like, nah, I'm a G, right? Okay, but let's do this then, okay? One, I'm gonna let y'all get some Starburst in a second, but what I need is, I need to,
You want
No.
me to raise them?
yes, please. Okay, because you named your variables, by the way, you can just type people back in and it'll automatically populate. There we go. Okay, and now here's the thing. So first things first, let's get some heights in here and then we'll get some hand sizes as well. So for the hand size, okay, for everyone who collected data and didn't draw my calculator, okay. Hey guys, if you grabbed candy, I need you to measure a hand size. What we're going to do that is pinky at the 0, thumb as far out as you can go, and how many centimeters it is from pinky to thumb. Okay, so spread it all the way out. How far from pinky to thumb? Alright, so if you grab candy, come measure your hand size when I ask you for your height. I need height in inches. So, height.
This is like very 6 or 7.
And span. Okay, so heights in inches. Charlie, how tall are you?
20.
5'11".
I'm
So
not, I didn't
71 inches.
Wait.
Evie, how tall are you?
Is it inches?
Pinky at 0.
5'4", so 64 inches. Leah,
Wait,
how tall are you?
5'6".
So 66 inches. Sophie,
Is that 23?
how tall are you?
Mine's 23.
20.
No, we're not holding.
20?
No, I only like it a little bit.
Sophie, you don't know what?
You're 5'4"? 64 inches. Kinsey,
5'1".
so 61 inches. Star,
What, 77?
Oh.
so you're you're 5'7".
Oh, no, it would be
You said 77. What'd you say?
I'm 6 foot something.
Is that
6
what-
foot
So
5.
72 inches.
I'm 6'5". I'm 6'5".
Okay, so 77, yeah.
I was right.
Yeah, you're
Yeah,
lower
it's
line.
5 cents and a half.
Okay, so I'm just gonna go ahead and say 5'8", be done with it. 68.
Oh my gosh.
Andrew, how tall are you? 6 foot. Okay.
Okay.
72 inches. Raina.
I think 5'3".
Okay, so 63 inches. Alright, who has their hand span so far?
22 inches.
Kinsey,
I got 16 centimeters.
16 centimeters.
21.5.
Who did 21.5? Raina?
There's a 56
What?
Okay.
No, I don't want to paint your nails.
Alright, Andrew, have you gotten your hand span yet?
23 inches.
Why did
23 inches? I don't think so.
Why are you talking?
Centimeters, maybe.
Yes.
Borderline.
20.
20
No, I don't want
centimeters.
to touch your butt ever since.
Stars.
Yeah, I don't want to.
22 and a half?
Don't ask.
Hey, who's telling?
What did you say back there, Andrew? On camera?
You are.
Sophie? Leah?
Are you-
How old are you?
No camera, I don't
I
want.
think I'm 5'3", I might have thrown up. Just my
I think I can get it. Well, it's so-
19.4.
Well,
And Phoebe.
Yeah.
All right.
you abbreviated it, that's why I did it.
Oh, Charlie, what was your hand
I'm not
span?
exactly rock. I just-
At 20 centimeters.
20 centimeters. All right. Hey, guys. We don't have time for you to enter this data yet or mark on people. But I'm going to send this data out to y'all tomorrow, but I want us to go ahead and look at this. So here's what we can now do, okay?
Right.
We said that height might be able to explain the amount of candy that someone grabs. So I'm going to go back to my data and statistics page. Apparently I didn't actually, there it is. All right, so where's my explanatory variable going to go here?
On the bottom.
On the x-axis. Remember, independent variable goes on the x-axis. And so I'm going to put height. All right, there's my heights. Where's that response variable of candy going to go?
The Y variable.
Y-axis. So candy grab. What is that called?
A dot
That
plot.
is not a dot plot because it's got two variables. It's a scatter plot. Notice there's a relationship here between someone's height and the amount of candy they grabbed. In fact, when you look at this, how would you describe the relationship between the amount of candy someone grabs and their height?
Random.
So it's positive.
It's like kind of like.
Directly proportional.
So there's another term. It's not, I will say this, it's not great, but I mean, I might be able to draw a little bit of a line in here. Does that line approximate those data points?
Yes. Yeah.
Okay, so you said positive, meaning that it's what? Overall?
Linear.
No, positive.
Continuing.
Positive means that the data is,
Increasing.
okay? That's a positive relationship, meaning that it is increasing. When I look at that data, would I say that that data is curved or somewhat linear?
Somewhat linear.
Okay, so positive, somewhat linear. And so we need to learn how to talk about what that somewhat is, but it is linear. And we have now hit the three things that you're going to want to talk about beyond context when we analyze our bivariate data. You're going to want to talk about if it is positive, so increasing or decreasing. If it is linear or not linear. And then how strong is that linear? We're going to talk more about the strength later. But I want us to look at this. We thought hand size might predict better. I don't know. If I remove these two data points, maybe. Those to me look like someone who might not be the most competitive person in the world.
Sad.
Maybe. That's a factor in there. If I take those two data points out, and that's not even you, I don't think. That would be Lorelai and, oh yeah, Lorelai and Phoebe. Yeah, Kenzie's, yeah.
You just don't have to drive.
If I take those two data points out, this relationship becomes very what?
Strong.
Positive.
Linear.
Positive and linear, right? It would now look like this. That's pretty darn close to being linear. Okay? Now, let me pass out the packet for this unit. Yeah, there's a packet, dog.
How big is it, Barry?
It's not as thick as last time.
Oh, man.
I literally said it's not as thick. Did you want it as thick?
Lola.
Oh, that's better than last time.
That's what I said. It's not as thick.
This is way better. It looks amazing, Mr. King. I'm sorry, Star is so inappreciative.
There's less homework. Saying.
There's less homework.
She gave me a sticker.
I was so excited to do
Compare
it.
hand sizes.
I don't-
Wait.
To the moment, just do second block.
Whoa. I have small hands.
Because you thought
But you're sorry, you just like messed up. But your hand is proportional.
Did I give anybody two?
I have
Did I already give one?
I
I already gave you one. All right, here you go. Okay, so
That's a big hand.
Oh. So just sorry.
Alright, so what I will point out is, we did something different than what Mathematic does, because they do something with Barbie dolls and rubber bands, and some people like it. I prefer the candy
I've
grab.
done that.
We did that in that.
Did you really? The Barbie?
And they're doing it in.
Okay, well I'm glad I didn't use it. Okay, so first off, what were the explanatory and response variables for us?
The explanatory was the height.
Okay, so either height
Hand size.
or hand size
Or size.
was explaining what?
The amount of candy.
Alright? So by the data we collected, we can go ahead and say, right, that a bigger hand size causes people to grab more candy, right?
Something like that.
No,
Someone said no. Why not?
it's correlated.
Well, my hand's smaller than yours. It's not the-
Oh, say that one more time. It's what? Oh, it's correlated, but not necessarily causative.
Causes.
Causation. Why is there not causation here? Why do we not know that?
Because
Right, we had no treatments, we had no experiment here. We can't assume or can't prove causation, but there's definitely a correlation between the explanatory and the response. Now, how many variables do we have? Two. Now, again, we could do more, but we'll probably focus on hand size and candy. Now, here's the question. Are they categorical or are they quantitative?
Quantitative.
How do we know they're quantitative?
We measured.
We measured, right? And we measured for the hand size and we counted for the number of candies, right?
Yes.
Okay, so we have quantitative. We're going to make a scatter plot. We're going to make a scatter plot. What I do want to emphasize and I want to point out before we continue is if we had two variables and they were both categorical, we wouldn't make a scatter plot. What would we make if we had? We could do a segmented bar chart,
A
or
mosaic.
even better is the mosaic plot. Don't forget that, okay? Nope. But segmented bar charts are valid, but we need to be aware that a mosaic plot is a little bit better because it provides information about what proportion the second variable is. So don't forget that stuff will be on your test on Thursday as well, right? So segmented bar charts and mosaic plots, things like that. Okay, so make a scatter plot on your own time. Please take that data with you. Here's what I want to focus on. Okay, describe the relationship displayed in the scatter plot. So, the relationship between hand size and number of candies grabbed is what? So first off, what have I already hit? I've hit the context. Remember, I'm analyzing data. I talked about context. What did we say earlier?
It's correlational.
So it is positive, meaning it is increasing, right? So it's positive. And what else did I need to say? And somewhat linear. Again, I'm saying somewhat for now. That is not the proper term. Linear is. We'll talk about what somewhat means later and how to actually determine if it's somewhat linear or not. Is there anything else that we could or maybe should address?
Potential outliers.
Potential outliers? I would say no for now. But what I want to make a note of here on the backside really quickly is one, when you make a scatter plot, what goes on the x-axis?
The independent.
Explanatory
So the
variable.
explanatory variable goes here. On the y-axis,
The response
the
variable.
response variable. And then you graph your dots. When you're analyzing this distribution, so to analyze it, you need to hit direction. You need to hit unusual aspects, so those are your outliers. We'll talk about other ones soon. You need to talk about the form, and then the strength. That's what it is.
It's duffs.
Yep.
Diffuse.
So,
That's fine.
the form was linear. The strength was somewhat linear. We'll talk more about that soon. Direction, positive, and then we'll talk about unusual aspects. So when you analyze bivariate data, you want DUFs. Direction, unusual aspects, form, strength, plus, what am I still missing from that?
Context.
Context. That is how you analyze bivariate data. That's all we needed so far. We'll use this bi meaning two, variate meaning variables. So bi, two variables.
How come that, the things that we did before it was not by
So we may have looked at multiple samples, but it was only one variable at a time. Now we're looking at a relationship between an explanatory and a response. Huh?
Take the calculator.
Yes, please take calculators.